I'm Keith Bowen. This is Hard Rock University, the Mojave Prospect 1 Upper Workings return visit. We got one sample here that ran 11 ounces to the ton. We're here to get a bulk sample of that because I had to hike up here last time. I did not have the capacity to take much home. This time we're going to take hundreds of pounds of material home so I can do some serious testing on it. As you can see, we're kind of up here on the mountains. Look over that way. And it's a great view, but it's frickin' cold this morning. It's like near freezing and a stiff little breeze. So let's go do some sampling. Here we are set up to sample the north pillar of the trench at the upper working. You can see the lighter colored vein in there. That's the same structure that on the other side assayed 11 ounces to the ton. On this side it's about 6 to 8 inches wide. On the other side it's about 12 or a little bit more. The pillar's about 6 feet thick and 6 feet tall. So I don't know, 6 by 6 is 2 by 2, 4 square yards at a quarter of a yard thick, about 1 cubic yard. There's about 2 tons roughly there. So we're going to sample this side, we're going to sample that side, and then we're going to go down the trench. There's another pillar down there that they were digging out underneath. Right here at the opening on each side, there appears to be some of this clear quartz stockpiled. There's some of it right there. We took a sample of that. The road is down the hill just a little bit, maybe 20 vertical feet. That goes to the truck and the generators in it. And yonder is the Colorado River. This is the other side of the same pillar. This is where we got the sample last time that was running 11 ounces to the ton. And here's where I got it from. Now this was just a couple of pounds because I had to put it in a Ziploc bag and put some other samples in there and pack it back down. So it was pretty small. Now the sample we took this trip was more like about 75 pounds or so. We had a demolition hammer and we had a pickup truck right there, so we filled a bucket and a half easily. And this also goes to show the value of large samples. Apparently the first sample, somehow I got a small rich pocket in there somehow. That 11.2 ounces per ton, there was a confirmation assay done on the exact same material at the lab. They do these cross checks and it came out almost the same. You know, still over 11 ounces, like 11.07 or something, I don't know. So the material that was sent was in fact pretty darn rich. This, on the other hand, I had 70-pound sample and I was able to, crush it and split it, and you notice it's not nearly as good. So the value of big samples. Now, it was very disappointing because I was really hoping that there was a fair amount of good high grade up here and we could at least start up there and make some good profits real quick. Doesn't look like that's going to happen. So let's go to the next pillar. Here's the south end of the trench, basically. This is the south pillar. And here's the vein type structure that the north pillar, south side, was running at 11 ounces to the ton by assay. Looks like it's from here to there. Average is better than 12 inches. As you come under here, you can see they like this stuff. It looks like they especially like that fault gouge looking material next to it. So those are blast holes. So from the measurements I've taken, call it 6 or 7 feet high, at least 12 inches wide, and about 18 feet long. So whatever that comes out to in terms of tons. And we'll take a sample here. And a sample here. And assay those. So now that we've looked at the upper workings, the 2 pillars of the trench, let's go down below to the adit that I was not able to get in last trip. Trench initially, there's a little mini winze. It's 8 feet wide this way and 6 feet deep currently. From this spot here, what's the current portal, to the back is about 37 feet. I'm going to take 3 samples. Right here we have a lot of fault gouge, and they seem to like this up above. So I'm going to sample this separately. Then this is the vein, and it's kind of hard to tell due to the weathering and stuff, but again, it looks like it's right up there to there, which would be like at least 18 inches. I think it's coming right through here somewhere. And then this would be your footwall. It's kind of hard to tell. Here we have what appears to be a horizontal offshoot. You can see there's clearly vein material here. It looks like it comes all the way down. This may be vein here. I don't know what's going on. It is just a mess. Typical. So probably ought to sample this. And let me get my flashlight. Boy, it's hard to tell. It doesn't look clearly delineated. That may just be fractured wall rock. Can't tell. There's so much efflorescence. I mean, you know, it's been coated by rainwater soaking through the rock and depositing stuff. See, here looks like mineralized vein there to there, about 10 inches wide. Looks more like wall rock here. Yeah, it looks more like altered wall rock than vein as such. There's a clear blast hole there. There's some of that fault gouge right along in there. So this is where you would expect the vein to be. But I can't really get a good visualization of the boundaries. Here you've got a fairly small, piece of clear vein that may just be surrounded by altered wall rock. That looks like brecciated vein material. Really don't frickin' know. That looks more like wall rock, but looks pretty silicious. A lot of quartz in it, it looks like. Oh well, sample it. I'll go ahead and call that the high grade at the end here. Low grade it, the face. This one right here, I call this high grade, middle, and that low grade there. And this will be fault gouge portal, and this will be high grade portal. That's got to be wall rock there. Yeah, or give her hell. Okay, so there's the information that we have. We got one decent sample from down below, better than an ounce per ton, almost 2 ounces. That's a big sample, so it's more likely to be accurate. But again, it's only one sample. So far, the gravity extraction has not been successful. On the other hand, haven't done a lot of definitive testing there. I've done a sample over my table, which I will do a little bit more to the materials first before sending it off to get an idea how well the table works. And if that doesn't work, we still have one arrow in our quiver that may work just fine. But we'll have to make sure we have good liberation. So also, that's the testing I'll be doing on that stuff that ran over the table is also going to be checking for liberation. If we can liberate it, as I say, we still have one good possibility before we give up on gravity separation entirely, at least to get it down to a concentrate. And when you're dealing with less than 1 ounce per ton on a fairly narrow vein, then that's, if you can't gravity concentrate it, if you got to go direct to leaching, you're probably not going to make it. You got to be able to quickly get into some cheap before you get into the expensive. It's my thought that looking at the workings, it was clear in the lower tunnel they'd done a lot more work. They moved a lot more rock. And they were also sinking those winzes for a reason, as that was not accidental. It was not on a whim. My thought is there may be an ore chute there that they were following down. Now, whether or not they just ran out of ore, or whether or not they were chased off due to World War II, that was one of the possibilities. That they closed this area for a bombing range. So if they did that, that's why they left. Okay, there may be some more there. If not, there probably isn't. But I think we need to go down into those winzes, clean the floor, which is going to be a bit of work, and take some samples out of that and see if there is a viable ore chute still going down. At this point, we have not identified what I would consider to be an economical resource, considering the small tonnages involved. So that's where we stand right now. Happy prospecting, and keep it safe out there.